All right, so the question is, what is the K? They give us the formula here. So we're going to fill in the pieces that we have. We're starting with 50 pounds. Which variable is that? A. So we know it's going to start with 50 pounds. E is a number. K is what we're trying to find. What is T? Are you getting 34.5? Oh, okay. So the time is 63 years. That's true. So we don't cut the time in half. What that cuts in half is what my starting amount is when this is gone by half. So what is half of 50? 25. That's where the half comes in. It gives us our amount after that amount of time is half of what we started with. We are asked to find K. We've plugged in all the pieces that we have. A very, very common mistake is trying to work the 44 in. 44 is the name. Titanium 44 is like saying Bobby Jr. or Richard III. Titanium 44. It's part of it. The 44 is not a number that works into the problem. So from here, we're going to solve for K. I would like to get K by itself. This is going to be the exact same process if we were solving for T. So what do I do to get K by itself? Divide both sides by 50. Ooh, that purple is really dark. I don't like that purple. A little bit brighter. There we go. So that's going to give me, on the left side, we're going to have 1/2. My 50s cancel out, and we're left with e to the minus 63k. I'm just switching it around because we usually like the numbers in front. Now what can I do to get that k by itself? My k is in the exponent. What tool can I use to get that k out of the exponent? What can we use? We have a test over this tomorrow, y'all. What tool are we going to use? How can I switch that so that that's no longer in the exponent? Huh? Rewrite it as a log. Perfection. All right. So we can rewrite this as a log. So we're going to have log base e of my argument, 1/2, equals whatever the power was, negative 63k. Log base e is also called what? Y'all, the music that's in the back, I'm hearing it up here. I can tell from the distance it's in the back. But I'm hearing lyrics up here, which means every single person between you and me can also hear them, and we have a test tomorrow. Turn your dang music off. There's a test tomorrow that's going on your report card that's coming out next week. Yeah, let's do this. I'm walking through a problem that's almost identical to one on the review. What else might that be really close to? Log base e is also called our natural log, ln, of 1/2 equals negative 63k. I still want to get k by itself, so what are we going to do? Divide by negative 63. So our most accurate answer is that k is natural log of 1/2 divided by negative 63. That doesn't really help me. So what we're going to do is we're going to type that into the calculator. Yay. We're where we say I have a fraction. We're going to get the natural log of 1/2 over negative 63. And you can type it in just like that. Please make sure you're practicing with these yellow calculators, not using your phone to do this, because you can't use your phone tomorrow. Almost every desk has a yellow calculator underneath it in the little bins. Yes, dear.
What should we round it up to?
It says third decimal place on the page that we had on the Bellwork page. So we're going to go to the thousandth, 10th, 100th, 1000th. So right here is where we're going to round. So 0.011. And we should tell you where to round. Okay, so this is the same exact process if we say, how long until? How long until we have this? Or how much do we have after 30 years? Same process. So this gives us that K value more than likely, especially the one on the review guide is going to say, using this equation where we've plugged all the pieces in, how long until some value, or how long until, or what is the starting amount if we go this long. So we're going to find pieces based on what we know. Plug in everything you can find and see which variable is left. Questions about the Bellwork question? All right, so I've got the review up here. I for sure want to do number 6. Because it has been a minute and a half since we graphed. After that, y'all get to decide what's going on. But I want to do number 6 together. Because it's been a minute. So get your review packets out. Again, get your review packet out. They're right there. On the table next to the turning bin. There's a test tomorrow, my friend. It's never gonna hurt you to practice more. All right, so how do we start when we're looking to graph one of these things? What are we gonna start with? We're first asked to graph log base 3 of x. That is my parent function for the transformation. Huh? Not log 3 base of x. I think I kind of think what you're thinking about, because our parent of my parent function uses that same base. We think of 3 to the x. 3 to the x is going to be kind of our parent of the parent function. We're going to think about x and y. Our exponentials, when we did that, same thing we would normally do. -2, -1, 0, 1, and 2. That gives us our y values of 3 to the -2 gives us 1/9. 3 to the -1 gives us 1/3. 3 to the 0 is 1. 3 to the first is 3. And 3 squared is 9. We're not graphing that one. That's just kind of our parent function. But we use that to build our parent function because our logs, log base 3, is the inverse of that. So my y's become my x's and my x's become my y's. If it helps you to draw out a third table like this, please do. So my new x's are 1/9, 1/3, 1/3, 1, 3, and 9. And my y's are -2, -1, 0, 1, and 2. This one we're gonna plot, my logs. We are not graphing my exponential. We are graphing the logarithm parent function. So my x is 1/9 and my y is -2. Somewhere around there. My x is 1/3 and my y is -1. My x is 1 and my y is 0. My x is 3 and my y is 1. And my x is 9 and my y is 2. So my parent function kind of looks like this. Questions on the parent function for this? Because the next thing we're going to do is kind of work down the C, D, and then we'll graph. I'm going to do C and D and then we'll graph this. So first thing we need to do is we're going to identify our transformations, which means I want my A, H, and K. So I want to know what A is, I want to know what H is, and I want to know what K is. So let's start with an easy one. What's K? 1. What does that mean is happening? Up 1. How about my H? -4, which means it's going left. How about my A value? 1, which means what happens? Huh? Because there's nothing in front of the log. So is there a transformation with that? Nope, nothing happens.
Oh, on the test, do we have to put nothing?
No.
Oh, because
You don't have to put it, I'm just putting it there so that I'm not leaving it blank.
I swear I got punched off the last test for not putting anything.
You have to describe what the transformations are, but if there is anything there, I was like, we can go through it and look at it. I was like, all you gotta do is point out to me if you see something that's weird. I can always change it. All right, so let's look at our asymptote. Think about that invisible wall that goes through logarithms. Where is our asymptote going to be on this transformation function? On the parent function, it's at 0. Because remember, it can't cross this wall. If I move it up 1, does that change where my asymptote is? No, where does it need to go? Right? Left.
Yeah, left. All right.
Yeah, it goes with my H. So our asymptote, our little wall that can't cross, is going to be where x equals whatever our H is. X equals -4. Our wall is going to look like this. That's our asymptote. Our whole function is going to be picked up and shoved to the left. That includes my asymptote, or the little wall. And the way we show that on our graph, or we find our points for our graph, is we're actually going to take our parent function and move it left 4 and move it up 1. We do that by going x plus h. So here's going to be x minus 4 and our y plus k, y plus 1. Using my h and k. So we're going to have 1/9 minus 4, which is -3 8/9. Our y plus 1, -2 plus 1, -1. 1/3 minus 4 is -3 2/3. Negative 1 plus 1 is 0. 1 minus 4, negative 3. 0 plus 1 is 1. 3 minus 4 is negative 1. That's meant to be a 1. 1 plus 1 is 2. And 9 minus 4 is 5. 2 plus 1 is 3. That gives us our points for our transformed function. And we can see pretty quickly that it comes right up to this wall and gets us really, really close to it without crossing it. That's how we know our wall is in the right place, is we are not crossing that wall ever. We're gonna hug right along it, but we're not crossing it. Fix that, 'cause I don't think the way that is curved. Our last piece on this graph, because this thing has 1.5 zillion pieces. If it has this many pieces, it's probably, lots and lots of points. We need to find our domain and range. I'm going to write them down here just because my tables went a little crazy, but it's still the same question. So our domain, which x values work? I'm looking at the blue function only for me, the transformed function. All of them? Can I?
Oh, never mind.
No. Anything before negative 4?
Yeah. X has to be bigger than negative 4, right? Or you can do it in our interval notation, where negative 4 to infinity. How about my range? All real numbers. It looks like it's going really just like mostly sideways here, but it is still going up. Really, really out as it goes up, but it is still going up. So this goes from negative infinity to positive infinity on those y values. Ooh, that's the wrong pen. Okay, so these graphing problems have a gazillion steps, and I wanted to make sure we had some time to practice that. What else would you like to work through, or would you rather have time to work independently? Yeah, go ahead, Julie.
Can we do like question B or something?
On the front? Let's see. One A and B we can talk through real fast, and then, oh, question 3. Yeah. Doing this without a calculator. Absolutely, there's a super duper easy trick for this. So I'm going to zoom us in. We're going to say, all right, we'll pretend it says equal x. What can I do to get rid of the log here? Switch this back around into exponential form. My base is 4. My power is, I don't know yet. And I want to know when that equals 64. 4 to the what is 64? To the third. So log base 4 of 64 equals 3. So when in doubt, give yourself an equals x. That works on these ones too, equals x. Same is true if you've got a natural log. You can set this equal to x. do you want to work through?
Isn't there a
4A. Absolutely. Let's condense it. So we're trying to make it smaller. I would like to get rid of all my logs, get down to 1 log. What should we deal with first? Our exponents. What becomes our exponents? The 5 and the 7. My 5 and my 7. My coefficients, those multipliers, become my powers. So we're going to have log base 2 of x to the 5th plus log base 2 of w to the 7th. Then what are we going to do? What operation can I deal with next? Yeah, multiplication. My addition is going to become multiplication. So I'm going to be down to just 1 log, log base 2 of x to the 5th, and we multiply our 2 arguments together, times w, oop, that's the wrong color, w to the 7th. Can I go any further with it? Or is that where we stop? That's where we stop. You're right. I'm just checking. Okay, so we do our multipliers to coefficients. We do our addition. That's going to be an A. Addition becomes multiplication, and subtraction becomes division. For expanding, it just goes the other way. Division becomes subtraction, multiplication becomes addition, and coefficients become powers. That backwards. Coefficients become powers. What else do you guys want to do? Yes, dear. 7. Look at 7. Okay, so this is kind of smushing together our BPA log BAP and our change of base. So what we're going to do is we're going to start with their little expression-y thing that they got here. Let's grab a color, purple. We're going to start with this piece. And we're going to go ahead and use our BPA log BAP to smush it around. So we're going to have log base 5 of 9 equals y. That's using our BPA log BAP thing. From here, we're going to use the change of base. Most often than not, when we do change of base, we use the common log. It's not the only thing you can use, but most of the time we use common log. They have used, it looks like, both natural log and common log, so we're going to do both, because those are things we can type into the calculator. So when we do our change of base formula, which one's going to go on top, the 9 or the 5? The 9. And the bottom is going to have my base, 5. So more often than not, we do the common log. So let's put log base 10 on both. Log of 9 over log of 5. Which option is that for the first part? C. So that's one of them. As long as the logs match, it doesn't matter which one I use. I can also use the natural log on both. Do they have that one in there? Yeah, it's A. The one thing I cannot do, so don't write this down, don't do this. I cannot mix and match. I cannot do natural log and common log. If I wanted to, I could do like log base 3. I don't know why I would, because that just gives me more work, but I could. I can use whichever log I want there. Usually we use the common log just because it's easy. So all the rest of those are wrong. All the rest of those are wrong. For part B on here, all we have to do is type this in the calculator. So we're going to have the fraction, we're going to have the log of 9 over log of 5. We just type them in. And the paper did say thousandths, so that's 3 decimal places. So 1.3652. So 365, this is where we round. The 2 makes this stay. So 1.365. Ooh, there it goes. 1.365. Good questions, guys. Keep them coming. What else do you want to go through? Number 10. Let's do B, because A is really, really similar. This is a real similar vein. B just has one additional step. Because I have 2 logs here. Ew. I can't do BPA log BAP when I have 2 logs. So we're going to kind of smush it together with what we did before, where we condense first. So if I'm condensing, what is my addition going to become? Multiplication. Multiplication between what? The parentheses. So my 6x minus 7. And what else? What's my my addition becoming multiplication with? Say it louder. I heard somebody whisper it, I think. The 5. So this becomes 5 times 6x minus 7. What can we do next? You can distribute. Absolutely fine choice right here. Log of, we're going to distribute the 5 to the 6x, giving us 30x. We're going to do 5 to the minus 7, giving us minus 35 equals 2. What else can we do? I can't add 35 to both sides because it's inside the log. How do I get it out of the log? Not divide. How about this? What base is on this log? 10. Log base 10. What can I do with this to get rid of the actual log piece? I would like to have no log, the word. How do I get rid of the log word? Can I put log base 10 of 30x minus 35 into the calculator? Can't put x's into those yellow calculators. They're not going to do it. Rearrange it. BPA log BAP. We're going to use that thing a billion times. So I'm going to take my base of 10, my power of 2, and it's going to equal my argument of 30x minus 35. This is a whole lot easier to deal with than that. What can I do now? I'm trying to simplify. I want to know what x is. You can add 35. Absolutely fine. What is 10 squared plus 35? 135. Sorry, it took me a second. My brain said you said negative, and I'm like, I'm pretty sure you didn't. Ten squared gives us 100. 100 plus 35 is 135. How do I get x by itself? Divide by 30. What do we get? X is... Oh, 9/2. Sorry. I was going to say, have we ever had it as decimal today? 9/2 or 4.5. So A has almost the same process, except we're going to go here. It doesn't have to condense. What is the base on our natural log? Not 10. E. This is log base E of 2x minus 5. Other than that, it is the exact same process as we had over here. Natural log has log base E. Other than that, it's the same process, okay? What else you guys want to go through? Or are we feeling okay and would like to have 10 minutes to work? Do what? Number 9? There's 9. Yeah. So this is just BPA log BAP stuff. Okay, I'm going to write it out. So we're going to have our B, P, pen, would you write P, A, log B, A, P. It's just got E's in there. That's the only thing that's different. So we'll go ahead and do A, because we're going to simplify it down. So our BPA log BAP, our base is E, so we're going to wind up with log base E of my argument, 81, equals that power, 17z. Log base E, we can write a different way, though. We can put this as ln of 81 equals 17z. You don't have to do anything else after that. We don't have to simplify. We don't have to solve for z. We're just writing it down. I mean, we could. Natural log of 81 is just a number. Divide both sides by 17. We could. But we're not. All we're asked to do is write it in logarithmic form. So this is your answer here. And honestly, if you get this far, you'd probably get most of the points, about 3/4 of the points, if we just get here. Because that's the hardest part. This is just remembering log base E is the natural log. I do love partial credit. So much. Let's see. Let's identify the transformation, which we've done. We've got, that's condensing, and then using your words. The story problem, we did one like that in the bell work today. This is identifying your transformations. That's identifying transformations. We've done a condensing, we've done a solving. We've talked through all this stuff. Do you guys want to do an expanding, or you guys just want to have time to work? I'm fine with either. Nobody responds, I'm going to assume it's work. Okay, you guys have about 8 minutes left in class. Use this time, practice stuff, ask questions. I'm here to help if you need it. I would love to help you with stuff. Practice using the calculators. That's really important that you guys know how to use those calculators, okay? If you can't use the yellow calculator, you're going to really struggle tomorrow. Please practice with it. But yeah, let me know if you have any questions. Turn your bell work in, because we don't have bell work tomorrow because it's test day. So turn your bell work page in.